There are many algorithms that used in asymmetric encryption. One of them is Diffie-Hellman key exchange, and this year 1976 is found, or agreement, we can call that, is about agreement between two users. Okay, two users secretly reach an agreement for sharing a secret message, and for subsequent symmetric encryption of messages. Another algorithm is RSA, that created by these persons at 1977. This algorithm, after we talk about that, is about a theory of number. Is related with theory of number. The key is created by some mathematical functions of numbers. Another algorithm is digital signature standard, the DSS, digital signature standard, that in 1994 is being found. And DSS, digital signature standard, uses an algorithm that is designed to provide only the digital signature function. Okay, provide only the digital signature function. Unlike RSA, it's not series of number. It cannot be used for encryption or key exchange. Another algorithm is elliptic curve cryptography, ECC, elliptic curve cryptography, that provides the same cryptography length as the RSA system, but as a smaller key. It means it's faster, of course. That use 256 bits. ECC key is the same as 3052-bit RSA key. Okay, which are 50% longer than the 2048-bit key that is used today. ECC, elliptic curve cryptography, reduce processing overhead. Security depends on difficulty. That is dependence of difficulty. RSA public key encryption algorithm, most widely accepted and implemented approach to public encryption. RSA is a block cipher in which the plain text and ciphertext are integers between 0 and n minus 1 for some n. The numbers that is related with the factor numbers, prime numbers, that number that is just divided with 1 or itself. RSA security depends on the difficulty of factoring large prime. The difficulty of factoring large prime means that the number that like 1, 2, 3, 5, 7 and 11, and that number that just divided by themselves and number 1, that are prime number. RSA common key size are 1024, 2048, 4096 bits. Okay. Others not important. The RSA algorithm makes extensive use of arithmetic operation. use arithmetic operation using module 0 to 1 arithmetic. For example, 19 and 5, both of them are prime number, and we mod this by this equal to 4. There are two interrelated components of RSA: the choice of public key and the private key, the encryption and decryption algorithm. They use the mod function to encrypt and for decrypt. Okay. Choose two large number P and Q. Of course, all of them are prime number. Before I told you that what's prime number. Compute N, P multiplied to Q, and Z equal to P minus 1 multiplying Q minus 1. For example, if P equal to 7 and Q equal to another prime number like 5, for example, at that time Z equal to 7 minus 1 equal to 6 multiplying 5 minus 1 equal to 4. 6 by 4. And then choose a number E less than N. Okay, that has no common factor with Z. And this way, I don't want detail about this, just I want to know that by this way we get the public and private key. It's an activity after we will do it for you. We will try to do it for you. And for your exam, it's important to could answer and search for this comparison, comparing symmetric and asymmetric for these subjects and for these functions: operation, efficiency, security, key distribution. What's the difference between symmetric and asymmetric? For example, how symmetric, what's the operation for symmetric and what's the operation for this? Efficiency of this and this. Security, which one is most secure? Okay, key distribution for both of them. Please try to find out the answer of this. It may be important for your final exam. Public key certificate. Anyone can forge a public announcement that some user could pretend to Bob the user, this user, to send a public key to another participant or broadcast such a public key. The solution to this problem is a public key certificate. In a sense, a certificate consists of a public key plus user ID. It adds user ID of the key owner with the wall block, signed by a trusted third party. The third party is a certificate authority, CA, that is trusted by the user community, such as a government agency or a financial institution. Either can present his or her public key to authority in a secure manner and obtain a signed certificate. The last thing is that the user can then publish the certificate. Anyone needed this user's public key can obtain the certificate and verify that is valid by means of the attached trusted signature.